All right, welcome back for this episode of Coding Your Career. I am joined today by Adam Taylor. How you doing, Adam?
I'm doing. It's Friday.
It is Friday. So Adam is an automation engineer. And so why don't you go ahead and introduce yourself, Adam?
Yes, as you said, I'm an automation engineer. Currently, I'm the lead automation engineer at Syn Clinical Labs here in heart of Silicon Valley, Sunnyvale, California. We're a mega lab doing dialysis clinical testing on large scale. We process upwards of a couple million tests a month. We just set some new records last month at our new facility we launched last year, where we were able to process over 1 million patient tests per day due to our automation rollouts. So one of the things they did bringing me in from the auto industry was looking at robotics, PLCs, controls, software, processes, maintenance methods. My previous roles were in the auto industry, robotics installation, Fanuc, Kuko, Kamal, Motoman, ABB, Nachi. Robots were robots, but basically heavy manufacturing for the automotive industry, where I did installation, tool design, controls work, simulation work, and maintenance work. I was at Chrysler the Ram truck plant for 4 years. My previous role before that, I was a contractor. So I nomadically moved where the jobs were at all over North America. So
That's
I,
a
I think that's my background.
that's a lot of different places. So let's take a step back. There were a lot of acronyms and things in there, so I want to
Yep.
hack it for the audience. So just first off, let's start off with because you're unlike most of my guests. Most of my guests are software engineers. They do C sharp,
Mm-hmm.
they do JavaScript, they do web development. Maybe they write servers. Okay, but in your case, you do automation engineering. What is that?
That is my old job. We had a joke. Someone gave me the Dr. Seuss book Bartholomew and the 500 hats, because every time you take off one hat as an automation engineer, you typically have another hat underneath there, and they just keep coming. So an automation engineer can be someone who does application engineering, so I can do vision systems work one day, or I may turn around and find myself working on a paint robot the next day, or a welding robot the next day, or material handling, or maybe doing controls logic work on a PLC, which is like the traffic controller for a large station of all the assets. Sometimes I'm doing Java to try to work on new AMR technology, which is mobile robots. But there's other days where I'm literally doing finances, the BOM, bill of materials testing, factory assessment testing, project managing teams, labor negotiations. The higher up you get in automation engineering work, they have a multi-pronged hat. It's definitely not a boring job, never tedious or dull.
It sounds like you do a lot of things. So one of the things I heard in there was robotics. All right, so I think that's the automation that most people are familiar with,
Yeah.
is the idea of having robots do things. So typically, what are robots used for?
Originally, the massive development of robotics globally was in the auto industry, and then following that was electrical manufacturing, so microchips, um, electronic devices. So that's our typical where you see the movies and shows, and they show the six-axis arm doing stuff, where it's material handling, it's welding, it's paint shops. They've been around since the 70s heavily. And the auto industry originally was welding lines that got automated, where you used to have hundreds of people putting these welds on, and that's all they did was the same weld or couple welds all day, every day, 8, 12 hours, 6, 7 times a week on a sheet of metal. Now a robot does it. And then paint shops were the next one to develop in the early 2000s. And now they're working in general assembly with like collaborative robots, which is really breaking out into other areas like healthcare, custom manufacturing, batch manufacturing, additive manufacturing, which is 3D printing. Robotics is now starting to finally break out where you're looking at things like having hands, two-armed humanoid agility robotics is coming out with a bipedal robot, autonomous mobile robots, which are now delivering groceries or shuttling services from warehouses to departments. In the last few years, we're really starting to break out of the traditional last 40 years of six-axis arms doing the same task bolted to a floor to more mobile, customizable things.
Basically, the way I could summarize it is that in the 70s, robots did simple things, right? They only
Oh yeah.
required one or two motions. With one motion, you can weld something, two pieces of metal together, and there you have that part of
Hmm.
the car. And then over time, robots got more sophisticated where they could do things like painting the car, like just slathering paint. But still, again, it's one motion. You slather paint on the car, make sure it's even. But now what you're saying is that robotics are starting to have more dexterity.
Yeah.
They could do surgery, they could cook burgers, they could deliver fragile items and deliver them unharmed, things like
Hmm.
that.
Yes, fast food is one industry that I almost went in that area when I switched out of the auto industry. That was one of the jobs I was interviewing with. Is they were looking at COVID. They couldn't find enough workforce. The cost of living is a real factor for fast food. Fast food is not a high-paying job, so they were looking at automation. And so restaurants are now coming out at KFC, McDonald's, Taco Bell, where you drive up and there's no workers inside. There's only like a couple hundred in existence, but they weren't there 2 years ago. In 5 years, this may be thousands of locations.
Just like that, with
It's
fully
coming.
automated.
Yeah, so like cities like Dallas, DC, Boston, they're starting to see these prototype locations where they're rolling these out. And I don't think people really are seeing a lot of it in the news yet because they're working out the kinks and the bugs. But when it does hit, I think it's going to really be large scale. You're going to start seeing like targets of next 2 years, 10% of McDonald's are going to go this route. And then 2 more years later, 25%. And when you're talking of 20,000 locations in North America, that's a lot.
That's a lot. That is a lot. Therefore, robotics then is, but it's not just robotics, so automation, right? Because there's other aspects to
Hmm.
it. Can you paint me a picture? What other aspects to automation engineering are there? If you don't do robotics, what else could you do?
So I have some projects I'm currently working on where like we're automating data analysis. We want to be able to receive our tracking on shipments at every stage, track temperature, geographical location, timestamps, and we don't want to have to manually receive this data. So we're working on types of inlay chips to put in there that can be read and upload data and use mobile devices so that we no longer have paperwork. We no longer have people manually entering things. It's all automated, which reduces cost dramatically.
I could definitely see that. What about the PLC you were talking about earlier? So let's
Hmm.
go back to like robotics. So just besides the robot, you said there's this thing called the PLC, which is
Yes.
sort of like the conductor for the entire cell. And then there's probably other things that are necessary to support the robot itself.
Yes. Yes, you have robotics, and then you have applications, and then you have like tooling, which is your end of arm tooling, and sensors and conveyors and accessory devices. And then the PLC is like the master traffic controller or orchestra pit conductor that manages what device moves when based on condition logic that's programmable. So there's controls engineers, that's all they do is PLCs, and there's usually robotics folks. And then you have like skilled trades, or the pipe fitters, electricians doing all the wiring. Then you usually have your application engineers who do all the programming and development of software and vision systems or welding systems or paint systems, depending on what the application is for that robot.
Okay, so this is a whole team of people, like, right?
Yes.
It seems like it's not just you're gonna walk in and just start programming a robot. Someone has to install it.
No.
Someone has to put up the conveyor. Someone has to put sensors. Someone has to program orchestrating all of these things. What are the team sizes then that you work with?
They always like to try to do as minimum as possible. So you get married to the machines when you're doing field installs, but typically it's starting out with design work and then simulation. So you can do this on a computer. You can build a work cell or line. You can do the throughput testing. You can do the recoveries. You can do some programming to upload to minimize time on site when you're traveling and install it. You can do clearance checks, safety checks, and throughput. Am I going to get 12 parts or 15 parts every hour or 80 parts? Is the tooling going to clear or is it going to crash? Is this robot going to hit this robot when it's doing this? And if so, do I need to put a signal that you have to wait at this point for this to clear? And that's what the PLC directs. And then every robot has to have tooling on the end of it to do its job. So whether it's a weld gun, it's got to have so much pressure on it. It's got to have so much current running through it. It's got to be there for so long. And then you got to fit the size and payload on it to match the robot. If you're doing material handling, you're trying to pick as many parts as possible with one giant material handler that has clamps to grab stuff. So if like you're an auto plant, you might have 18 models of doors. Ideally, you want to get as many on that one end effector as possible. Or if you do have to switch them out, which is another process, another set of tooling, minimize how long it takes to do that between and how many racks you have to be able to hold these. But yes, you start looking at a lot of different intricacy parts. There's vendors who do nothing but 6 sensors or type sensors or cabling. What type of cabling you have and where it's located on a robot can have a great effect on whether the data comes through. Maybe it's not shielded correctly, so now you end up with noise in there and lose data connection. Maybe the circuit board needs to be deprogrammed. So yes, it's not a one-person job, but there are people who can wear quite a few hats, because when you go out to install, there might only be 5 people installing a workstation or a couple workstations.
Really, just 5 people?
A couple people, yes.
To do all this work. It just sounds like you had to lay the electricity, you had to set up all the mechanical parts. So really, this could be like a boots and hard hat kind of job, like going into a factory or going into some industrial area and doing this kind of work.
It was the reason why I shaved my head. I used to spend quite a bit of time in hard hats and you sweat, and yeah.
Wow. Here's the thing. I think that's great for some people who might want more hands-on work than sitting in an office. How big are these areas where you use automation? Like I know, for example, car factories, I've been in one. They're massive. And there could be tons of robots just everywhere doing all sorts of stuff. Can you give me a little taste of the scale we're dealing with?
Yeah, so my last job was at the Ram truck plant in Sterling Heights for Stellantis Chrysler. And we would produce about 1,400 trucks every single day. 6-7 days a week. About 336,000 trucks minimum a year had to be coming off that line. So every 42 seconds a truck was being built. That facility had 2 paint shops, 2 welding shops, and a general assembly shop, and down the street was a stamping shop. Those 5 centers combined were about 2.5 million square feet.
Wow.
So basically a small city. During the course of a week, about 10,000 people worked in there. We had about 2,000 robotic arms in place and about 30,000 PLCs.
All just going at once, just putting cars together, spray painting them, putting doors on, putting bolts in, putting them together. That is insane.
Yep. We had our own rail yard just to have the chassis delivered. Trucks, we had hundreds of docks of trucks coming in, and these trucks would back in, and robots would scan the trailer, read the manifest, and unload them, because everything is just-in-time delivery, so it's sequence-oriented. So we would issue the order 3 hours to the vendor down the road that we need seats built that has to be here in this order because it's going on this exact truck, going to be on the line that everything else has to go on.
Oh, so this is very precise, too, because they're trying not to have any extra inventory.
Inventory is a huge cost and consumer, and then you have to have more MLM, material logistics management, to do that. So being able to sequence everything in there cut costs dramatically.
I think the benefit of automation from the company's perspective is pretty clear. They can cut costs left and right, it sounds.
Yes.
So what about people who want to get into the industry? Because for the code of your career, I want to talk about the different things that people can do. And I think that my job is like web development. Like I make apps and things like that, which is great. But maybe some people want to do like more hands-on things or something different where they get into a factory or they install stuff. Maybe they want to drill things together. Do you find that you have to do various things? Because you said you wear different hats, right? So sometimes you have to program. Sometimes you have to get your hands dirty.
Yes.
Tell me more about that.
So I started out, my first round was basically an apprenticeship. I came in, someone I knew, I was originally inbound for law, a graduate degree, so very logical methodologies. So I came in, took some aptitude tests, and they said, you know what, we're willing to train you, but it starts at $14 an hour. And this was like 2015. And so I came in, and they said, we'll send you down to Mercedes in Alabama. First day on the job, I'm on a plane from Michigan to Alabama, drive out to middle of nowhere at a German plant, meet a guy in a hard hat, and in we go. I started learning how to recover machines, and a couple of weeks later, started learning how to write programs, and then I started learning how to do wiring and how to check the controller boxes and fuses, and then I started learning how to, literally at times, sometimes having to weld or help an electrician wire something, and basically just a lot of hands-on. It was straight up an apprenticeship, pretty much, for trade skills, and kept doing it. I ended up making more money than I think a lot of peers who finished law school. without student loan debt.
That is true. So
So,
wait a
but yeah, you
second
can do
though.
all sorts of activities in these. You can do simulation work where you sit in an office. You can do robotic programming. You can do controls. You can do tooling design. You can be an electrician. You can be the guy who builds the robot controllers and wires the robots and ships them out. Or you can be the guy who goes out and does the installation and deals with the clients. Yeah, there's a variety of jobs, but you're typically a lot of options to not sit at a desk if you don't want to.
One thing I want to hit, I want to make sure people listening get this point. So you got your first job and you didn't have a certificate or anything, like no magic
Nope.
piece of paper? And they just took you.
Yep.
Why do you think that was?
I knew some people and they were working there. That was one. And I was willing to work for not that great of a wage starting out, but I was looking at the fact that I wouldn't have to go get a certification, which means stopping making money, time. To me, making some money and doing some bills versus spending a ton of money and wondering how to pay the bills, I took it up. I was also interested in it.
You learned on the job. So basically, then they'll take you, and then it sounds like you learn completely on the job, right? Like it's very
Yes.
hands-on. So they actually put you on the floor with the actual live robots that were actually working on real cars.
Yes.
How'd you feel about that?
That was most people I would recommend starting out if you can at a build shop where you can work in an environment of building the cell and the testing and getting to the factory assessment and then it goes out to the floor. I went straight to the floor.
Okay.
So it was a little bit of a baptism by fire. Not everyone's cup of tea. So yeah, there was a little bit of a learning curve.
You clearly you've moved up the ranks, and like you said, the earning potential is so much higher. That's why I tell people that you may start off okay with software engineering. The same thing, the earning potential is way up there.
If you're willing to do the job and you're willing to travel and learn, people who do field installation work can easily make $250,000 a year.
Wow. That's why I want to also talk about the hours you work, the traveling. What's the lifestyle like? Because I know part of it is you're not just like working in one place. You'll be in Georgia, then you'll be in Colorado, then you'll be in somewhere else.
And that goes to which hat you decide to park your wagon in or camp. There's folks I met who did simulation work, and they were great at sitting at a desk. They literally could hear robots from their desk, but never went out and saw the robot. And the build shop was 99% of the building, and that's fine. They didn't do any travel. They had a 9 to 5 or work from home during COVID. And that's what they did. They did online simulation and design work in CAD, and then they handed it off, and someone else did the tool making and all that. There's people who do tool making and maintenance, and they stay at one plant. And that's what I did when I got married and had my kid. For the last 4 years, I was doing maintenance at the plant I did my last install at. There's folks who do the build shop, and then they are married to that equipment and go out and do the installs. So you spend possibly a large portion of your year traveling. You may be at the build shop and you just stay there. There's some folks that stay in the build shop, and there's folks that they go out with the equipment. And they're usually the ones making the most money. But yes, I traveled 5 tours of Mexico, Canada, all over the U.S., Wisconsin, Alabama, Ohio, Kansas, Washington, California, Texas, West Virginia.
Wow.
Tennessee, Kentucky. Yeah.
That's so basically everywhere.
Yeah. It depends on what's your cup of tea. If
you enjoy traveling, there's definitely opportunities to do it. And that would also mean that like automation is, because it's industries are now adopting it more and more. So the demand for automation engineers is only going to go up, which means that you're going to be everywhere. We're talking like fast food, delivery, grocery stores, warehouses. Like, where do you see it expanding over the next, let's say, decade?
AMRs are exploding, autonomous mobile robots, and right now one of the things that's really starting to develop is applications on top of them, like mounting a collaborative robot, which can work next to humans onto it. Those things can go and pick up cards, deliver cards, drag things, pick up stuff. So delivery systems, which some of them are now developing where they can climb up the racks in warehouse, grab the bin they can RFID read, bring it back down, automatically update the inventory system, and then deliver it out to the floor.
Wow.
So you have other ones which are now, they're looking at Agility Robotics is now coming out with the first humanoid robots, which are bipedal. One of the challenges they're facing is they're so far ahead of the game right now, they don't meet safety requirements to work next to a human because the robot can walk around and use arms. Other robotics that are now developing just the torso up with 2 arms, so you can now put them at a table and they can work on tools. The biggest factor is trying to get the hands worked out. So collaborative robots right now are becoming popular. Robotics in Japan, one of the things they're looking at is senior home care and senior care. Hospitals are looking at these android robots that can read facial expressions and body language to be the front customer rep when you walk into a hospital. It's exploding
Surgery.
right now. Yes, surgery is currently looking at options for robotics because then certain surgeries you can pretty much, right now they do teleoperations. So a doctor could be sitting at their house, potentially if it's set up, and they could perform surgery on someone halfway around the world if the hardware is there. So you might have a specialist who could perform without having to travel if the hardware is on the other end. So you could have a specialist in Moscow performing surgery on someone in South Africa if the hospital has the equipment to do it.
That's absolutely amazing. So people who do these really very specific surgeries, then the range, the number of people that they could perform the surgery on pretty much is wherever on
Increases
earth.
dramatically,
Yeah,
yes.
that's amazing. And companies are making this investment then. They're making, because
Oh, yeah.
I'm sure the initial investment is pretty hefty.
Automation is expensive up front, but when you look at the return on investment, if you can replace FTE, a full-time employee who's $50,000 with a system that costs $200,000, but that system runs for 10 years,
Yeah.
you now have a guarantee. You don't have a liability. You don't have to worry about benefits. But people think there's no jobs. And it's when we got rid of making horse and buggies, we made cars. Now we have car mechanics, salespeople for car parts, tire manufacturers, testing for vehicles. Things change. A couple CEOs I've heard in technology have come out in this unit in the last few years, and they were saying, look, if you're a truck driver currently, you're probably not going to be out of work before your career is over. There's so much demand for truck driving. If you're 18 and looking at a career, will you be impacted by automation of self-driving trucks during your next 4 decades of working? Most probably.
Reasonable. Yeah. Because they're going to make the investment because the benefit is there.
Yes.
Okay, it's just the way it is. So that's why automation so intrigues me, because it seems like there almost isn't an industry that doesn't benefit from it. Like manufacturing, truck driving, fast food, healthcare, surgery. It just seems like it's very pervasive.
They call it the 3 Ds: dull, dangerous, and dirty. People
Dull,
don't
dangerous, and
like
dirty.
doing dull, dangerous, and dirty. No one wants to work inside of a paint shop booth breathing in fumes.
Fair.
No one wants to haul biomedical waste when a robot can do it. No one wants to work inside of a smelting furnace when they're standing next to 300-degree heat metal and 800-degree heat metal. I ended up at a contact I worked with. He would go down to a foundry in Ohio every 3 months and bring a new FANUC robot and replace the one, because all this robot did was insert the rod to get the metallurgical readings to make sure it was pure enough when they were pouring smelted metal. And the splatter would hit the robot and eat through the casing and eventually wear out the robot. They were fine spending $50,000 to rip out a robot and drop in another one every couple months, upload the same software, run it. Versus trying to have someone stand there with a pole and stick it into this to get a reading.
And I'm sure no one really volunteered for that job.
No one wants to do that job. And they're like, and it sounds expensive, but every time they were pouring these cauldrons, it was a couple $1 million worth of melted metal. So every 3 months for them, if they had to spend $50,000 versus, here, Bob, go put on this heat suit and hopefully we don't cook your organs.
You check the metallurgical. Yeah, exactly. So therefore, these robots are really doing some really dangerous stuff then. So
Yeah.
It's not even just your molten metal example, but I've also heard of ones like dealing with nuclear waste, for example.
Yeah.
No one wants to do that.
There's no reason why humans should be doing that. Yeah.
It's just plain too dangerous. Okay, so therefore then we could really see the amount of positions that open, the need, the demand for people who are skilled on automation engineering to just do nothing but explode the next decade or two.
You got to develop the machine. You got to build the machine. You got to install the machine. Then there's the programming and updating. Then there's maintenance, which never ends. It's a job that no one really likes to think about, is maintaining. These robots have to be greased and they have to be cleaned and they have to be serviced. upgrading them, switching tooling for next application. Yeah.
So that leads me to another question. AI is affecting my line of work, especially a lot with the ChatGPT and the sort of GitHub Copilot, right? Writing code and things like that. How do you see AI affecting automation engineering?
Right now, due to the fact that the niches of these robots have their own code, I don't see necessarily ChatGPT replacing that. Although I guess ChatGPT, since it can pull off the internet, could figure out how to write an OLP, an offline program. It still has to pass the snuff test of reality, so someone has to be there to do it. I can see that definitely affecting software engineering. I remember a few years back there was a story coming out of London where an app was being developed that basically took an industry of lawyers out of business, where people would get parking tickets and they would end up having to go to court and they would spend like 400, 500 pounds to have an attorney go and solve this issue for them. And it would wipe it off the record so their insurance didn't go up. And they would have to answer all these questions and call me with the attorney. Or they could download this app that would take their information and for 20 pounds would go through all of the internet based on this information and represent them, and was getting like 99% of people out of their traffic tickets were reduced.
Wow, that is an extreme
So,
success rate.
like, judges noticed like 6 months later, like, I haven't seen so-and-so attorneys lately, and find out they moved to a different area of law because they didn't have any business model left.
Wow. The AI just basically, the AI has a 99% success rate. Yeah.
And matched words and was like,
that's amazing. But it did, like I said, but that's like a high-end job too. Like one of the things that's amazed me about AI systems recently is that they came for artists and lawyers and programmers first, not the dirty jobs. They came straight for the like higher end, white collar, typical kind of job, and that's what we're seeing. What do you see with like robotics and things like that? Do you see AI having a place there?
See, I think robotics has already been doing that. It's been cutting, like Stellantis is about to go into labor negotiations with the big three for the UAW contract in middle of September. And the big three, Chrysler, GM, and Ford, are going to be really facing a challenge of the fact that for the first time, they have so much automation they've been increasing on. They're down to general assembly is the only spot left for workers, and they want to get the labor cost down to like $16 an hour for workers, where in the 80s, your starting wages was like $28 an hour benefits, which will break the back of the union. So cost for labor has just been going down while automation has been increasing and getting even more profit. So we're seeing that they've already been going after some of these jobs that are manual based. Having the AI, I can see why it's targeting the jobs like that, because being able to replace an attorney or downsize your attorney bill, those are huge costs for a company to have an attorney on the books or software engineer on the books. But yeah, if they can get something that can do it for a fraction of the cost, I can see why those industries targeted that, and I don't think that's going to slow down.
That does make a lot of sense. Do you think like that we may have like robots that will use like AI to do like cooking or predict delivery or using sort of predictive systems?
The next mixture is going to be trying to get so you can do predictive learning. If you can put actual tangible fingers and hands on robots and legs, which is what we're starting to really break into, and you can have them working next to people. Things like senior health care can be handled, where most people are so busy working and age population is really starting to reflect around the world. Japan's having a major problem with it, Korea, Italy, where the population is aging and the next generations are not having as many kids because capitalism is great at putting that pressure on. I think one industry that's going to explode in the next probably decade or two is potential robots in the home that can cook, clean, and take care of seniors, or be an option for senior care. Because then right now we're looking at wages for PACE programs. My grandmother's going through it. She's just had a stroke. She moved back home. After the stroke, she's to have people come by and do cooking for her and some assistance. But these folks are being paid on Medicare, and they're being paid like $12, $16 an hour. So it's a high turnover job. It's not a really well-thanked job. But senior care in a lot of countries is only going to grow. So,
oh yeah, especially like in places like Japan has had that for the past decade. Korea's caught up, and China's the other one where their population for the first time, like they're not as used to that, so they're not having
child program for 4 decades is going to have consequences.
That is
Hopefully the
true.
Chinese don't hate me for saying that.
So basically, the AI could just is basically truly expand
Yes.
the capability of what automation can do. That's what it sounds like truly, like it could do very human-like things. And if it could
Yes,
do very
one project
human-like
I'm looking
things,
at now is instead of trying to have multiple robots doing one set application, could I have a mobile robot, whether it's an AMR on wheels or bipedal, that has arms that can do multiple tasks with a vision system? So I can say for the next 4 hours, you're in this department doing task 1, 2, 3, and then now you're in this department doing task. So having a robot that can clean the house, if that can become affordable in homes, that will be a multi-trillion-dollar industry. No one wants to clean a house.
if you ever played the video game Detroit Become Human, that sounds remarkably like that sort of
Yes.
like video game where you have essentially everyone owns a robot in their home, which
Yep.
essentially it does all the cooking and the cleaning and everything.
That's a whole nother level of robotics I'm not currently in. I'm dabbling in stuff that's developing, but I think in 10 years, I think there's going to be an explosion of that.
So then back to the idea, back to Code of Your Career, right? So back to the theme of
Mhm.
this channel is so essentially then they're going to need people, like a lot of people. Most people think in their head, I got to have a certificate. I got to go get my degree in mechatronics. I got to go have the special piece of paper. It sounds like if you,
Mechatronics wasn't even around 20 years ago, really. I got around it with an apprenticeship. Even if software develops with AI, someone still has to write the original code. So until the AI can, on its own, generate new code, not mimic, copy, someone's still going to have to add that repertoire. And with the expansion of tooling and technology, there's always going to be new stuff to write. Yeah, I think people, but the technology is growing faster than what a degree program can do. To have a degree program to be an absolute requirement, you need to have someone who has the ability to get a PhD and become a professor and have 10 years of experience. 10 years ago, we didn't have bipedal robots from Boston Dynamics. How are you going to have an engineer work on that until they have to go study at Cornell University Engineering School in order to do that?
because by the time they have the curriculum set up, and by that time it's already changed 10 times over.
Yes. So that's to your advantage. If you're willing to jump in there and work and learn, you may not start at the greatest wages, but you can quickly see some increasements.
And that's where for you, essentially, I want to talk a little bit about that sort of because your background's interesting in that you were doing something that was totally not engineering, not mathematical, not wearing a hard hat and going to a factory, and now we're here. So,
My work before that, actually, I was a registered state lobbyist in Michigan, and I did consulting work and poll data analysis work. So I would do statistical data on different policies based on this data. Will this likely get passed, or what are the buzzwords to get people on board with this, or what is the chances of this budget proposal working versus this budget proposal on this proposition? What's this gerrymandering map going to look like as a result of this? So a lot of statistical analysis work and policy work. Yeah, I was in a suit and going to the Capitol, or behind a keyboard crunching numbers in Excel and databases, which is what led me to the other one was the logic of building arrays and tables and trays. And
all that good stuff.
so that kind of led to the other thing. So if you like solving puzzles, automation's really never ending puzzle, and it's never done because we're always building the next one.
That's really an interesting point, though, because it seems like the core of how you're able to do automation engineering was the fact that you were able to work with numbers, think
Mhm.
logically and rationally, and be able to analyze. And if someone's able to do that, even in their current position, that base skill transfers.
Yes.
So another
Problem
question,
solving.
yeah,
Problem
essentially,
solving. This is an industry you can find a niche in.
I want to also talk a bit more about specifically like what you use on the job. So, like when I think robotics as a programmer, I
Hmm.
work with C# at my job for the most part, and I do like
Hmm.
high level programming languages. I rarely, if ever, have to like get close to the metal. When I think robotics, I think of like C plus or like assembly. What kind of languages do you work with? What sort of like tech stacks do you actually have to like deal with when doing automation?
So there's people who do application engineering. If you're developing the vision system that goes on the camera that's mounted on the robot, you might be doing languages you're dealing with. If you're dealing with some of the other equipment like a sealer system or a welding system, you're dealing with WeldSpark and you're dealing with data tables heavily. So some of the stuff can be quite old. I've had stuff where it's literally PLC one and it's literally a glass box and it's one line and you have to roll through it. But that machine's still working, so they're not going to replace it.
Makes sense.
And it ran on floppy disks, and I'm talking Fuji double density, 800 kilobytes, double sided to make that, 8 by 5, which I have one still sitting on my wall. PCMA cards, I had to use those in Mexico. The FAT32 style formatted where I'm using LS files, where I'm literally Notepad writing line by line and hoping I don't make a syntax error and then uploading it.
Wow. What about, go ahead.
There's other ones you deal with, like you can deal with RoboDrill, which is basically CNC machining. It's basically where it's not so much robot, it's a box, and drills come in and change themselves, and they bore out and they make the engine or a metal block, and they make the tooling, the bolt, the washer, the nut you need, the threading, but basically take chunks of metal and make it into a finished product, and that's all M code and G code, and then that's from the 60s, basically. Ancient. It's all coordinates, basically, one line at a time. You get some of this other stuff, and it's basically a spinoff of C+, turns into Carol. And then, of course, each robot manufacturer has different ones. I dealt with Kawasaki's, and they're a bunch of math nerds. Everything was based off of basically algebra, parentheses, and numbers.
Wow.
So if you're great at math, you can pick that up and run with it. If you're not, you're going to be beating your head on the wall a little bit.
So then, are you saying then that robot manufacturers have each their own sort of programming language that they use for their robot?
It's a niche. So a good robot guy can figure out how to pick it up and in a few days be running. So you're constantly switching, because I go to one job and I'm doing paint on a FANUC, and then the next job I'm doing a KUKA and I'm doing welding, and the next job I'm doing a Nachi and I'm doing material handling, and then the next job I'm doing FANUC and it's with a vision system.
And they're all different.
And right now one project I'm working on is KUKA, and it's an AMR system with a robotic collaborative arm from them on there. Instead of their traditional language they've been using for the last 40 years, they went to all Java, because it's integrated without having to switch as a compiler between the different texts into one system. So they're going in a direction that is more applicable to more users. And yeah, you end up, sometimes it's not easily transferable, but if you know a robot, you should be able to go to another one in a few days, be up and running.
So this is interesting, because I guess they're leveraging the Java compiler, because the idea of Java is that if you have the Java can run anywhere you want it to. It doesn't really matter. So I think that's probably why they picked that. So therefore, you don't necessarily have to know all these ancient languages. You can even now in the future, they're moving towards doing Java, which a lot of programmers are well versed in.
They're speeding up. When I started out, when I was on KRC Generation 3 at KUKA and Mercedes, they're now on KRC 6. And in less than 10 years, we went 3 generations.
Wow. Okay, so it's accessible then. Because one thing a lot of programmers, they are surprised, like my bootcamp students, I tell them, you're not always going to be working on like the latest and greatest of React. My first job, we did a whole code base in Visual Basic. And it like surprised me, but yeah, there's an actual, by the way, there's a production app running out right there right now, completely in Visual Basic.
I had a job in Mexico. I got down there. I was the only one who carried a floppy disk reader and a PCMIA card reader and adapters and card slots. And I learned that because I got into a job a few months before, and I was never going to find myself in that position yet. And I was the only one there. And people were like, well, go on Amazon and we'll order it. We're in the middle of the hills of Mexico. It's not going to be here tomorrow. We have to be running in 4 days. So I'm plugging this in, and I'm FAT32ing formatting, and I'm doing Notepad files, and I'm dumping the stuff in on a machine that was commissioned in 1985. It's older than me. And they're laughing, and I'm like, and I'm laughing because one of the guys, he's been doing this for 30-some years. We call him the Beast because he looks like one. And he's just laughing. He just goes, you've been around a bit. And I'm like, sometimes you deal with some really old. But you got to get the job done.
Right. It's at the same time, though, the prevailing mentality is that it works, right? They bought it. It works. The robot will be running. Go with it.
At the end of the day, the company wants to know, are they making money and is this functional? You can have, that's one of my problems. I can see some of the latest, greatest toys and I'm drooling over it. And I know we're not going to buy that for another couple of years because the cost hasn't come down yet. And some of these techs, we will buy in early, but we're looking for that break point. So we'll be early, but we're not going to be the first, or we want to be a first because some of this new stuff, it's great to look at, but it's just not applicable. A
Right.
lot of these startups I vet out, I'm like, are you going to be around in a year? Is this just an idea? How many units are actually out in the market? It's great you did this test on a trade show, but can you actually deploy this real life in an application I need? And if so, without customizing costs being millions of dollars to do, versus can we dumb it down? Can we just put 2 sensors on there and get rid of this fancy 3D laser scanner? Yeah, but it won't be as great, but it works.
Right. And costs way less.
$15,000 and I know it works, or we can spend $2 million and we don't know if it works. Guess which one the company's going to go with?
Yeah, surprise, surprise.
Yeah.
So one thing you touched on a bit earlier that I wanted to talk about was it seems that there's a little bit of this brotherhood kind of going on. Because the community is tight-knit and you guys have, like, deal with the same sort of issues, it seems like there's a little band of brothers thing going on.
Yes. So I laugh. One of the reasons I learned so much I did is I met people who were very humble. You may not politically agree with each other and you may not have any backgrounds in common. You'll call each other and we always pick up the phone. Robot guys, we jokingly, you have your network of people and you'll call and you might not talk for months. You call and be like, 2 a.m, you answer the phone. What's up? I'm on night shift. I have this down system. Remember that job we did 2 years ago? You were the vision expert. Get me on the phone. Let's video call. Let's do this. Let's look through it, and you find it. And you might not hear from this person for another 3 months. Hey, how's the wife doing? Anyways, but I got this issue and yada yada. So calls, text messages, WhatsApps, because you don't know if they're traveling, and RoboGuide, Robo Forum Online. I'm laughing. There's been times where I'm Googling and I'm finding a forum blog from 2010, and I'm going, that looks like exactly the fault code I'm dealing with.
That would have to be because I think because again, it's such a mishmash of technology. It's such a people just flying by the seat of their pants trying to get the thing to work because you have tight deadlines. Then you have to band together.
Yes. So I've worked with people who we have a good working relationship. I'm probably never going to go out and have a beer with. And I've worked with people where we've gone out and had a beer with, and I can't believe we went out and had a beer with.
But you know what? I think in a way though that's nice because like it's good to have your work have some meaning, but your work to also have community.
Yeah. One thing you do see is a lot of the same people traveling around doing this work is we don't have enough of us. There's not enough. And technology is only growing. That's another thing we joke about as cowboys. Like, if you're at a job and you really just don't like it, something's going on with that job, you really could jump on your horse and ride off into the sunset to the next job. Like, if you're willing to travel, you could be in another job. I was at KUKA. I came back from my one tour of Mexico, and they decided they were going to do a restructuring, and they let go of a bunch of contractors. So there was just eeny, meeny, miny, mo, one of every 3 of you is gone. It was like 11 o'clock on a Friday. 2 o'clock on Friday, I was working at Fanuc.
Just like money. That. For more money. This is why I tell people, go ahead.
It was just like, okay, I may make some phone calls. And I literally went and had lunch with a buddy, and he was like, all right, you're available. I'm going to lunch. So we went to lunch, and I was working Monday. I took the weekend off. They wanted me to work that weekend. I took the weekend off.
That is so much. I tell people, like, part of the allure of tech is not just the salary and not just the other stuff. It's the fact that they need you. I got laid off, and I was only out of work for 4 days. That was it. And I went on vacation. That was my response to being laid off was I'm going on vacation and leave y'all and say bye and just chill in the sun. And then I have a job waiting for me. So that is the other, I think, strong aspect.
You are the wizard. You're the knowledge worker, and the knowledge worker is not going away. The tech may evolve, but even if the AI takes over, they're still going to need human beings because we're here. So if the day we're out of work is the day I'd worry about maybe humanity's survival. But yeah, tech industry. It's a wide range. It's not always just sitting at a keyboard. I've met a lot of people who can't stand sitting at a keyboard working from home. You let them weld stuff and wire stuff and program stuff, and they'll build you a machine that welds 50,000 cars next month.
What would you say as like your final piece of advice? Like maybe someone's listening to this and maybe they think this is a cool, interesting profession to go into. What would be your piece of advice to them?
If you're interested, do it. You don't necessarily need a certification. It doesn't hurt to go do some schooling. I wouldn't take out too much debt on it. Contact some built body shops, contact some shops, contract houses. You might not make a ton at start, but it's going to go up in a year or two, 5 years from now. It's going to go up. If you're young and willing to travel, you're definitely going to find work. There's no shortage. If you're not looking to travel, I'm older now, different stage of life, family, kids. There's plenty of maintenance work. People don't usually like to think about it, but they need maintenance specialists. Someone's got to tell the electrician and the pipe fitter at a plant, whether it's union or non-union, how, because their job is it needs this many voltage, it needs to go this type of wire to this point. They have no idea about the design of that machine, the robotic arm.
Right.
That's where you come in. It doesn't have to be automotive industry. It could be building solar panels, wind turbines, boats, planes. Boeing is using very advanced robotics that are mobile to build their plane systems. SpaceX is trying to currently 3D print spaceships. 3D printing is exploding. That's a whole nother industry. You could be doing CAD design, work in 3D printing, which I do as a small business on the side. The stuff's out there.
That is absolutely amazing. Last question. What was the coolest project you've ever worked on?
There's cool. Oh, that's hard. Some of the projects I've worked on have used magnets to pick up stuff for Caterpillar that weighs 50,000 pounds. That literally, when it would turn, even though the controller was 50 feet away, it would blow its own board and it would lose its input-output module. We had to put up a sign. No one with a pacemaker or metal fillings and teeth or metal body parts may enter a 500-foot radius with the lights on, because we had a plasma magnet. Another one was we were building ship engines for like oil tankers. This thing was so big, it would pick it up and try and have the robots work on it, but the bolts would snap off, and the bolts were 3 inches thick.
Wow.
Because the size of the engine being built was already a bus. It was 40 feet long, 20 feet tall, 30 feet wide. And they're trying to put these piston valves in. So it's like a motorcycle engine 300 times bigger. Another one I did was frame turnover at where we would pick up the chassis half built with 2 robots that are 30 feet tall with camera systems. These things were 5-6 feet wide, thick metal. And it would pick it off an AGV, rotate it, and place it back down with 1 millimeter of accuracy. 36 different models. So if we were wrong, if it came down, it's going to smash the crap out of that AGV.
Oh my God.
We had to do this every 40 seconds.
And just over and over again.
1,400 times a day.
That is amazing.
We used to pick chassis off of trailers. The trailer would back in. Robot would come down a rail, 30 foot tall, vision scan it, find the 40 slots, know what type of chassis it is, know how to pick it up because everyone was different, and load it to a carrier in the sky.
That is
these
breathtaking.
chassis were 1,500, 1,800 pounds. So if that fell, you're going to hear it.
All right. Thank you, Adam, so much. If that doesn't inspire people, like if the cool factor of that does not inspire people to like at least look into automation engineering, I don't know what will. But thank you so much for talking with me today. It's been an absolutely fascinating conversation.
No problem. Thank you for having me.